Hello. All of you can hear me? Am I audible? So I'm here to tell you about a very important concept of statistic, and which is also a very important concept regarding to artificial intelligence. As I can see, all of you, some of you are students of MS Data Science, some of you are students of DBA or MBA. So this particular lecture is for everybody who wants to understand the concept of data science. So statistic is actually the base of data science, and this is the most important lecture for statistic because when you start with statistic, you start learning actually that what is the central tendency, what is the measure of dispersion. Then you keep learning regarding the probability distribution, which is a very vast topic where you learn that what is a normal distribution, what is the continuous and what is the discrete distribution, which is the normal distribution and the Bayesian and the binomial distribution. And then you learn more about the correlation. And this topic today is about the parametric and the non-parametric methods. So this topic is very important because this topic is used for every researcher. In case if you are doing research by using the quantitative variables or by using the qualitative variable, this is a very important topic for you because you have to know that how you actually proceed with the methodology of the research, right? So what are the methodological techniques that you do in research? So in that case, this is a very important topic for everybody, right, who is basically doing research. So here what we're going to do in this particular boot camp, we are going to start up with the basic. That means I will first of all tell you that what is the hypothesis, what is the hypothesis testing, and what are the various techniques in the parametric and the non-parametric. So there are vast amount of methods that they are in parametric and non-parametric. We won't be able to cover the all the methods, but we'll try to cover the most of them, right? So that you understand that how important it is. And then I will also be sharing you this slides, the slides that I have actually created. So I'll be sharing those slides also with you so that after the lecture also you can see the slides and you can understand. Yeah, because it is very difficult for you, because it's more of mathematical techniques that is involved in this particular presentation, right? So in case if you want, you can keep a pen and a paper, right? A copy and a pen with you so that you can also understand, you can also write down whatever the mathematical concept that we are doing over here. So after that, when you're reading the slide, it will be very easy for you to understand, right, later. So it's a suggestion from my side that it's better that you have a copy and a pen available with you now so that you can write down the things that have been told you during the lecture that are important, right? This particular, when you are even going for the interviews, so the most of the things that I've covered over here, it will be asked in the interviews also, right? These are very important concept. Statistic is a base for any kind of technology that you have to learn. Yes, recording will be available, but you should first understand it in live lecture, right? In any case, if you want to just go for the revision, then you can go for the recording. But it would be advisable to be there in the live lecture and to understand it over here, right? So let me share the screen with you. All of you can see the slides. I hope the slides are visible. Yes. Okay, great. So I think most of you have joined. So we can start the lecture because the timing, we are exactly right on timing. So let's start the lecture now. So first of all, we will be starting with the hypothesis, right? So we'll be doing that. What is hypothesis? This is the first thing that we'll be doing, right? What is hypothesis? Then we'll be doing that. What are the hypothesis formulation, right? what is hypothesis, what is formulation, what is confidence interval, what is significance, what is null and alternative hypothesis, how do we test this, what is type 1 and type 2 error. So this is the most important part of this lecture that we are going to do over here, right? So let us start with it. So first of all, what is a hypothesis? How do you define a hypothesis? So it comes from a very like a Greek word, which means under, like, so it is, firstly it was called as hypothesis, and later it is called as a hypothesis, right? So this is actually a Greek word. So now when we talk about hypothesis, what actually is hypothesis? That means whenever we describe any research problem, right? So whenever we are describing any research problem, we described it in the form of a hypothesis, like an explanation. So any research problem, or suppose when we do a literature review, or when we make a conceptual framework, so all the important facts that a researcher is actually thinking, we actually put it in a form of a hypothesis, right? Then we come to that, what is a research problem? Suppose when you're doing a research, your research problem can be either a descriptive, it could be a difference, or it could be an association. So descriptive means, suppose if I want to know that who is the best batsman in the world. So this is a descriptive problem. So for that, I just want to know, I need to collect the average, of the batting average of all the cricketers. So if I have this data, I can find out that who is the best batsman. But suppose if I need to find out that which team is best. So that means now what I'm doing it, I am going to actually collect the batting average of all the batsmen, but I'm going to sort it with by the country. So that means there would be a difference, right? So here I'm actually, my research quotient is that I'm taking different batsman data, right, from different countries. So this is actually sort by country. And when I'm talking about that, does the batting position affects the performance? So that means I am actually collecting the data of the different batsmen with respect to, or we are sorting it by the position. So our research problem is now divided into three types: descriptive data and difference, and then association. So how do we formulate a hypothesis? So when we are actually formulating a hypothesis for any research topic, we just want to know that what is actually the gap that is being covered, right? So whatever is not done that we are trying to cover, that is the first of all we formulate the hypothesis. It's basically on previous study. So literature survey is also a very important part of hypothesis. Then we basically do the personal investigation, right? When we do a hypothesis analysis, and we have a discussion with the expert, the people who are of that field, we take the suggestion from those people, and based upon this, we actually make a hypothesis, which is actually a testable statement, which is still not true. We need to find out that whenever we make a hypothesis, whether we are going to reject the hypothesis. So we always have two ways. That means we call H0, which is called as the null hypothesis, which first of all means that there is no difference. So that means there is no difference, there is no significance, there is no effect. So that is called as null hypothesis. And when we make H1, or sometimes it is written as HA, that is called as the research hypothesis, or that is also called as your alternate hypothesis. So that means that there is a difference, there is an effect, there is a significance of that particular variable. So that is the H1, which is also called as your alternate hypothesis, right? So that is, if we have to look at some methods, and based on those methods, we have to find out two important values over there, which we will talk about later. And then we have to define based on that value that whether we reject the null hypothesis. So when we say we reject the null hypothesis, it means that already this is, that means that there is some association between the variable. So that means we are accepting this hypothesis H1, or we can say HA. And when we say we do not reject, when we do not reject the null hypothesis, because we use this word do not reject, that means we are saying that there is no association, right? So we are accepting this. So there are two ways to accept the hypothesis and reject the hypothesis. So what is the characteristic of good hypothesis? That obviously the hypothesis should have an empirical reference. It should be conceptually correct, and it should be very specific. It should not be something which it is like very generic. It should be specific according to the problem that has been stated, it should be solved, or it should be testable based upon the techniques, whether it's the parametric techniques or the non-parametric techniques, and whatever the theory or whatever the problem that we have, it should be related to that problem. So now we come to this particular graph, which is a Gaussian graph. It is also called as a Gaussian graph, and it is also called as a normal distribution graph. So if you have done your this statistic chapter, data science for statistic, you would have known that this is normal distribution graph. That's a basically a continuous, right? That is also called as a continuous graph. So what we use over here is that this part over here, this is called as a mean, right? So everything that is coming on this side from this to this is called as your 95% confidence interval, right? So anything that is coming within this area, right, that is called as your acceptance area. So this area is the acceptance area, and this area, which is your alpha by 2, because when we actually propose a hypothesis, we always talk about that what is a significance level of a hypothesis. Now, what is a significance level? Significance level is actually a threshold that we actually define, that what is the probability of rejecting this hypothesis. So when we have a two-tailed test, we'll talk about the two-tailed test and the one-tailed test. So let's say when we have a two-tailed test means this is alpha by 2, this is alpha by 2. So that means here, if we have a 0.05, let's say our significance level is 0.05. So when we have the two-tailed test, so then it is 0.025 over here and 0.025 over here. So this area alpha by 2, which is 0.025, this is called as your rejection area, right? So if your value falls within this area, which is the black shaded area, then it is a rejection area. If your value falls within this area, which is your 95% confidence interval, then it is called as your the acceptance area. So what is the significance level? The significance level is also defined as 1 minus confidence interval. So what if confidence interval is 0.95, then your significance area is 0.05. If confidence interval is 99, then your significance area is 0.01. If your significance interval is, if your confidence interval is, let's say 90, then it is 0.10. So I hope it is clear that what is the normal distribution. I hope this is clear, everybody. You can write down in the chat if it is clear. Yes. So I'll be asking you with short intervals that whether the things are clear or not. So I want you to write in the chat whether it is clear or not. Okay. Because then I can move forward, because when I'm actually seeing the slide, I cannot see the chat window. So in between, I'll be coming to the chat window and I'll asking you that whether the thing is clear or not. Okay. So now we come back to our topic, which is your normal distribution, right? So then we come to, okay, so we already talked about the acceptance area and the rejection area. So this area which I'm talking about, that is called as your acceptance area, right? So this area is the acceptance area, right? And this area is the rejection area, right? So, okay, this is mu. So whenever we are talking about hypothesis, we always take population mean, right? Which we'll talk about further also in detail. Whenever we talk about hypothesis, we always take population mean. So this population mean is called as mu, right? And sometimes we also take as a sample mean also. So that is called as S. So S is your sample mean. And this mu is your population mean. So whenever you know where mu is written, so that is considered as your population mean. Because whenever we are taking a hypothesis, we cannot take the entire population. Sometimes it happens the population is like very large. So therefore we take a sample, right? So see, this is important for you. This is very important for you, but you will understand it much later when we be solving the problem. critical value greater than calculated value. Now, what you're going to do over here is that with the help of the method, parametric method, you are going to first of all find out the calculated value. That is what you will be finding out. Let's say I'm taking a test, which is a Z test, right? This test is used for the larger sample, and this is a parametric test. Now, based on this test, there is a formula, and you basically find out that what is the calculated value, right? Now, what you will do is based upon the Z table, you will be finding out what is the critical value. So two values that you need to find out in order to identify that whether you have to reject the hypothesis or you do not reject the hypothesis. So when your critical value is greater than the calculated value, so critical value is found out with this Z table. So this is a critical value, right? And this is the Z test. You get this. This is called as your calculated value. Okay. So this is what you have to find. You have to find the calculated value and the critical value. So you have to find that whether the critical value is greater than calculated value. So this value will always form in this acceptance region. And whenever the critical value, suppose your critical value is coming out to be 3.45. and your calculated value is coming out to be, let's say, 2.1. So here the critical value is greater than. So it will be always in the acceptance region. And when your critical value is somewhat like it is 3.45 and your calculated value is, let's say, 10.78. So definitely this would be coming in the rejection region over here, right? So whenever the critical value is always less than the calculated value, it will be in the rejection region. And whenever the critical value will be in the critical value is greater than the calculated value, it will be in the acceptance region. So this is for you to remember, right? It is very important point for you to remember. Okay. So if both the means are different at 5% significance level, right? So as I talked about that 95% is a confidence interval and 5% is the significance level. This is for the two-tailed test. This is for the two-tailed test. So we have two tails. One is over here, which is your 2.5%, and one is over here, which is your 2.5%. Now let's go to the, this is already done. Okay. How do we make a hypothesis? As I told you, there are two ways to test the hypothesis. So what are those two ways? The two ways is, first of all, with the p-value. You should know the p-value, how to find the p-value. So first is this, and second, I have already told you the critical value. So these are the two ways in which you can check your hypothesis. So here we are just telling about the hypothesis. The methods we will talk about after just few minutes. We will talk about the parametric methods and the non-parametric methods as well. So hypothesis, the first thing that you have to do is that, okay, now first of all, let me tell you what is the p-value. Okay, so as I told you, the methods that we are doing over here is there are different methods for the parametric and different methods for the non-parametric. So let's say when we are talking about the parametric method, there is a method which is called as your Z test. Then there is a method which is called as T test, right? So these are all your parametric methods that we'll be doing. Or there is a method which is the ANOVA method. And there is a method which is the which is your correlation method, which is your multiple linear regression. So these are all the parametric methods. You must have done some of them. Yes. Now p-value is the probability value, right? So whenever, let's say, when you did the multiple linear regression and this simple linear regression, there you would have calculated the p-value for a variable, right? And based upon p-value, you would have find out that whether the variable has a significant effect on the independent variable, has a significant effect on the dependent variable or not. So if your p-value is less than 0.05, then we actually reject the null hypothesis. So this is the condition that you have to remember, that if your p-value is less than 0.05, then we do reject the null hypothesis. Reject the null hypothesis means null hypothesis says that it do not have any effect. What is a null hypothesis? Null hypothesis always state that a variable does not has any effect on the other variable, or it do not make any change. This is the null hypothesis. But whenever we are doing any kind of test and our p-value is less than 0.05, we reject the null hypothesis. It means that the variable has the effect uh, on the other variable. So that means we are, whatever we are stating in HA, which is your alternative hypothesis, we assume that that is true, right? So the first thing that you do in your hypothesis testing is you state that what is HO. HO means that no effect, no significance. Always it is like that. That H0 means that there is no effect and there is no significance. Now HA, what does that mean? That there is a significance, there is an effect. So that means there is a significance. That means it is just the opposite. When I say HA means H0 means there is no effect, HA means there is a significance. And after this, we specify the significance level. I told you what is the significance level. Significance level is alpha. So let's say it is 0.05. If alpha is 0.05, I know my confidence interval is 0.95. As I already told you that 1 minus alpha is your CI and 1 minus CI confidence interval is your alpha. Then you basically decide that what is the sampling distribution. So you decide that obviously the sampling distribution is normal. Then we can go for the parametric test. And when the sampling distribution is not normal, it is distribution free. Somewhere it is like positive skewed or negative skewed. Then we are going to go for the non-parametric test. Then we have to collect the sample. We have to calculate the probability value. And if the probability value is less than the significance value, we will reject the null hypothesis and we will say that this variable has the effect on the other variable. So we are going to reject the null hypothesis. But if your p-value, suppose if your p-value is coming out to be, let's say here if the p-value is coming out to be like 0.1078. So if this value is greater than this your significance level, then what we will say, we are going to fail to reject the null hypothesis. That means we have to accept that this is true and it is having no effect on the other variable. So this is the first thing that we do when we do a hypothesis testing. So this is for everyone, the BBA students, the MBA students, and the MS Data Science students. This is for all. Whenever you're doing a hypothesis testing, this is how you actually make your hypothesis. So when you're writing a research proposal, you actually define that what is your hypothesis. So the first thing that you can test your hypothesis is by using a p-value. Now, what is the second that we can do is, the second we do is with the help of critical value. So here it is not mentioned over here, but we can do the same with the critical value as well. So how we do it with the critical value? Let me tell you. Let me just make a new slide for you to understand. Okay. Now what you do over here is, let's say you have your here you have the same thing. The same thing is there that you have your H0. It's getting bigger. So here the same thing, you have your H0 and HA. You define this. Then second step is you define the significance level. Similarly like that. The significance level is defined, which is your alpha. So it's like 0.05, you have the significance level. Then you have to define that what is the distribution. After the distribution, you decide, you collect the data, right? You collect the sample and then you basically collect the data from the sample. After that, you find that what is the calculated value. So you have, suppose you have a t-test over here. So you find that what is the calculated value, the t calculated value, and you define, and from the t table, you define what is a t critical value. So this is a second type of the method in which you basically identify that whether you reject the null hypothesis or you do not reject the null hypothesis. Suppose if your t calculated value is greater than the t critical value. That means if your t critical value is less than your calculated value, now see this you have to remember, you reject the null hypothesis. So this is I did not have this slide, so I'm just making it for you, right? Then you reject the null hypothesis if t calculated is greater than the t critical value, right? Otherwise, the second option is like, what is else if this is not true? What you will do if your t critical value, right, is greater than, or we can say, okay, let's talk about the same thing. If t calculated value is less than your t critical value, then you were going to fail to reject the null hypothesis. So if your calculated value is greater than the critical value, you are going to reject the null hypothesis. But let's say if your t critical value is greater than the t calculated value, then you are going to fail to reject the null hypothesis. So is that fine? Are you able to understand? All of you, please write down. Okay, you are new to data science. Okay. See, even if you're new to data science, I am telling you new concept. I'm not telling something which requires some prerequisite. Okay. I'm just telling you all the new concept. This is nothing like there's a prerequisite of something. I'm explaining you from the scratch because I'm telling you the concept of hypothesis testing. Then I'll be going to the parametric method and the non-parametric method. So this is all linked to, first of all, that what is hypothesis, how do you test the hypothesis? And since I'm explaining you now, you may not be able to understand, but when we will go to the methods and there I will be solving the problem, the case studies, you will understand it much better, right? So now it may be an issue that you are not understanding because you are just seeing the graphs and you may be getting confusing, and with the I'm telling you the like the formulas, like it should be greater than less than. Don't get confused. We are just going to go to the methods, and we will be revising the same thing when we'll be talking about methods. So just have patience, be there with me, right? And I'm sure that after the end of the lecture, you will be taking a lot of useful information with you that you can actually use in your research. Okay. Okay, thank you. So let's get back. So already told you about the, now let's move to the next part. Okay, type 1 and type 2 error. Now this is very important, that what is type 1 and type 2 error, right? So we need to understand that what is type 1 and type 2 error. Type 1 and type 2. Now what happens is when you are actually doing hypothesis testing, after that you are going to formulate your results. Whenever in data science we are formulating our results, that is always done in the form of confusion matrix. What is this? This is a confusion matrix, right? What is a confusion matrix? Confusion matrix is used to identify. So confusion matrix is like, it could be a 2 by 2 matrix, it could be a 4 by 4 matrix, it could be a 6 by 6 matrix, right? So what is it's used to identify? Here we are making a 2 by 2 matrix, right? So this confusion matrix is going to have the parameters that, or the variables that we are using. So here the variable that we are using is that either we are going to reject H0. So I'm telling you from here, right? Either we are going to reject H0 or we do not reject. Do not reject the null hypothesis H0. So here we are saying H0 is true and here we are saying H0 is false. Okay. Now look at the situation. We reject H0. Okay. We have rejected H0 and H0 is false. So this is what? This is correct. You should reject if it is false. Suppose if null hypothesis is false and you have rejected it, you have done a correct decision. So this is a correct decision that you have taken, right? Similarly, Do not reject H0. You did not reject H0 and H0 is true. So you did not reject it and it was true. So again, you have taken a correct decision. So this verbatim correct decision is exactly what should be done. But sometimes it happens when we are doing a hypothesis testing, we may reject a hypothesis which is actually true. So there is an error. That is an error. That is a type 1 error. So reject H0. H0 is true, right? So this is a very important thing that we also need to see, that whenever we are finding the accuracy of any particular method, we have to identify the what are going to be the true positive, what is going to be true negative, what is going to be false positive, what is going to be false negative. And the accuracy of any method is identified with the help of true positive plus false positive plus true negative plus false negative and divided by the total number of values, whatever is the total number of values that we have. So see, what is the correct decision? Correct decision is uh, okay, just a moment, just a moment. Here, what we are doing is, this is the total number of value is this. So the accuracy of any method that we are doing, it is identified by true positive plus true negative divided by the total number of values. So total number of value is true positive plus false positive plus false negative plus true negative, right? So when I say, so this is the accuracy. We have to just identify that how many true positive and true negative we have and divided by total number of values, right? That is going to give the accuracy of a method, which we'll be doing later. Now see, reject H0. Reject H0, H0 is false. So this is a correct decision. So that is called as your true positive. That means we rejected this and it was false. Do not reject H0, H0 is true. So that is your, we did not reject it, it is true, that is your true negative. Next is reject H0, H0 is true. Now this is called as your type 1 error and this is what should be reduced. These are called as your false positive. Sometimes it happens that we have a lot of false positive result. So this lot of false positive result because we are actually rejecting a hypothesis which is true. So this becomes a false positive. So there should be a reduction in the false positive value. Otherwise, the accuracy will be affected. Similarly, we do not reject. That means it was false, but still we did not reject it. So that is a type 2 error. So this has also been asked in interviews most of the time, that what is a type 1 error and what is a type 2 error. So again, a type 1 error occurs when a null hypothesis is true, but we mistakenly reject it in favor of an alternative hypothesis. So that means it was true, but we rejected it because we have favored the alternative hypothesis. So this is a type 1 error. This is called as your type 1 error, or we also called this as false positive, right? Type 2 error means we did not reject the null hypothesis, right? We failed to reject the null hypothesis, right? Even if it was false. That means we did not reject it, we accepted the null hypothesis, but it was false, right? So that is also called as type 2, and it is also called as your this is also called as your false negative. So just tell me, is it clear, everybody? What is the false positive? What is false negative? What is true positive? What is true negative? Is it clear? The confusion metric is clear to everybody? Maybe you can get the recording. Don't worry. We will upload the recording, right? So you will get all the recording. You will get the PowerPoint. Everything will be given to you. So, but now just tell me, is it understood what we are talking about? The confusion metrics? Because it's a very important part of your research, that whenever you're writing results, your results are always written in the form of confusion metrics. That means how many, what you proposed, what was there, and you also did the same thing. So that is true positive, right? That means it was false and you rejected it. So it's a true positive. So we can say it's a true positive. It was actually false and you rejected it. So that's a true positive thing. Now what other thing is, say that it was true, but you rejected it. So it was true, the null hypothesis was true, but you rejected it. So that is called as your false positive, right? You're giving a false positive values. Other is saying that it is false, right? It is false, and you do not reject it. So it should, if it is false, you should have rejected, but you do not reject it. So it is giving you false negative. And it is true, and you fail to reject it. You do not reject it. So if it is true and you do not reject it, that means you are doing a correct decision. So that is your false negative. Okay, that's great. So now let's back to the lecture. So here this is the case where they are I'll a small case sorry I will explain. So see, this is what H0 looks like. This is what your H0 looks like. H0 is your no significant. Always I tell you, whenever you write a null hypothesis, you always write no significance. So that means there is no effect whenever you're writing null hypothesis. And H1 is saying there is a significant effect. So H1 is the always the opposite. So there is a effect, right, which is the opposite. Now see what it is saying. Let's come to this. Researcher conclude. Now see, imagine a researcher is investigating the impact of natural light on occupant well-being in office building. A say researchers conclude that natural light has a significant impact on well-being when in reality it does not. So it is saying that researcher is saying that it is having a natural uh, is having a natural impact on well-being when in reality it does not. So what does that mean? It is your type 2 error. Okay. Researchers conclude that the natural light has a significant impact on well-being when in fact it does, right? So that means it is saying it is having an impact, and also it does. So that is your true negative. Researchers conclude that the natural light does not have a significant impact, and it does not. So it is saying it does not have an impact and it does not. So this is also your true positive, right? Researchers conclude that the natural light does not have a significant impact well-being when in fact it does. So that is your false positive, right? So similarly, these are the four output that we got from these hypotheses. And this is your type 1 error, which is false positive. Type 2 is false negative. So whenever accuracy, we don't have to find over here, but later when you'll be going to the machine learning, there you will need to find out the accuracy. So whatever are your true positive, this value and this value should be more. Then only the accuracy will increase. Your true positive and your true negative should be more. If your false positive and false negative is more, your accuracy will be decreasing and the method will not be reliable. And depending upon all the value, let's say when we add all these values, this comes out to be, let's say 1500. So that means all your this denominator will have TP plus TN plus FP plus FN, right? So this all will be 1500 and some values will be over here. Let's say this value is coming out to be 1200, right? And your true negative value that is coming out to be, let's say it's coming out to be 200, right? So even we can say the accuracy is good. Only some of the things are going in your in your false positive and false negative. But if the value of true positive and true negative is less and false positive and false negative is more, then definitely the accuracy will be affected. Okay. Now we come to the methods. We have already done what is hypothesis testing. We have already done that hypothesis testing, how we actually propose the hypothesis testing. We did that there are two methods to check the hypothesis. One we did was the p-value and the other we did was your critical value, right? We find that what is the calculated value and we for p-value was less than 0.05, then we reject the null hypothesis. And next we did was the critical value. If the critical value is critical value and your the value that you have calculated, right? So if your critical value is less than the calculated value, then you reject the null hypothesis, right? So this is the two things that you have covered in your hypothesis testing. Now we are going to cover what is the non-parametric and what are the parametric tests. This also depends upon the data. When we are doing the parametric test, we actually take the data which is your data which is like more of the quantitative data, right? Interval scale and ratio scale. Whereas for the non-parametric data, we do not take the quantitative data. It's more like a qualitative data, like ordinal data. Ordinal data means, for example, nominal data is like anything, any name or anything that is a nominal data. Ordinal data is the data which you have basically defined. Let's say your let's say how was your score? Was it excellent? Was it very good? Was it good? So these are the category. The categorical data is your ordinal data, right? And these data are your quantitative data. So parametric methods we use the uh, quantitative, and there we use the qualitative. So parametric test, it's again based on the ratio and interval. And these are the tests. See, we will not be able to cover all of them, but we'll be covering the most of them. T-test, Z-test, ANOVA, regression, Pearson. So we'll be doing all these methods over here. Regression, I think we already done the linear regression, multiple regression many times. Non-parametric methods are the distribution. Now they do not depend on any distribution. They are depending on normal distribution, the parametric methods. Non-parametric, they are free of distribution. They do not depend on it. So let's say when you have a graph like this, or let's say when you have anything graph which is like bimodal, so you use a non-parametric method for this. And when you have a graph which is like a normal distribution, you use a parametric method for it, right? So any non-parametric method do not have any distribution. So this is the basic thing for the non-parametric method. Whenever you make a graph and based upon the graph, histogram you make, you can easily identify that whether you have to go for the parametric test and the non-parametric test. So it's usually the nominal and the ordinal data. So we will be doing the chi-square test, we'll be doing the Wilcoxon test, we'll be doing the Crucicle Valley test, we will be doing the Spearman test, we will be doing, right? So we will do the Candle test. So all these tests we'll be doing for the non-parametric, right? So these are the tests, Z test and T test. These are your parametric tests, and we will be doing them. And then F test is your it's an ANOVA test. Correlation test, it is used to find the correlation between the two variables. Multiple linear regression, it's very easy. In this, we have one dependent variable and we have many independent variables. So we find what is the relationship between the independent variable and the dependent variable. So Z test and T test. Now come to the first test of parametric. So what is a Z test and T test? This is the formula. See, Z test is used when you have your larger sample, right? So when they are the larger sample and when the standard deviation is known, we go for the Z test. And T test is basically when we have a small sample size, right? And when your standard deviation, population standard deviation is not known, then we go for your T test. So it is very important to identify that when we have to go for a Z test and when we have to go for a T test. Okay. So now as you can see, it is used for the larger sample size and T test is used for a smaller sample size. This is the formula. Now see, formula is very easy. Don't get confused. It is written as X bar. What is this? This is the mean. Whatever is the mean, you write it over here minus mu. This will be given to you. This is the population. This is the population mean divided by standard deviation of the population, and this is divided by under root 10. This is the number of the number of samples that we have. So this is for the Z we have. Now what is this standard deviation? This standard deviation of P formula is not written. It is under root of xi minus x mean whole square divided by n. Okay, I want you to write this formula in your copies because that you will understand it much better, right? So Z is what? Z is always given as these all values will be given to you. So you don't have to worry whenever any case study will come or whenever any problem will come, you will be easily able to find out these values, right? And use a Z test. Either you can use in your Excel or you can use manually. You can also do. You can use in R. You can use in SPSS. So anywhere you can use this test. It's very easy, right? So this is given to you. Again, I'm telling you what is the formula. The formula for X and T are just the same. The only difference over here is that in Z we are using the standard deviation of the population and we are using the number of sample for the population, whereas t-test is used for the sample. Now what is sample? Sample is a subset of the population. So let's say I have a population, and when the population standard deviation is given, right? So I will write like this, right? And when the mu is given, which is mu means, which is the population mean, then I'm going to use the Z test. But when the sample is a subset of the population. So when a sample standard deviation is written as S sometimes, right? And it can also be written as this, right? So these are the two ways to write a sample standard deviation, right? When a sample standard deviation is given and its formula, the formula for a sample standard deviation is this. For population, it is divided by n. For sample standard deviation, the formula is the sample, it is this. So let me just. So the formula for the sample standard deviation is this. It is under root of summation of xi is the value, minus mean of whole square divided by n minus 1. And for the p value, I will just write it down, right? It is the same formula, but the only difference is it is for the population. So this is divided by n, right? So we have to use this formula. Now let's say this case study is given. The sample population density is 90% per hectares in hill city. So mu is given. Mu is given to be 90. So this is what? This is the null hypothesis that they have given, that the sample population density is given to be 90. So what we will give mu? Mu is given to be like mu is equal to 90. Right? So this is given H0, which is your null hypothesis. Alternate hypothesis is opposite. So it will be mu is not equal to 90. The sample population density is not 90 per hectares. And so whenever we write not equal to, it becomes a two-tailed test. We know that because it is not equal to, it can be less than, it can be greater than. So it becomes a two-tailed test. So this is the city is given and density per hectares is given. Mean we have to calculate. So mean you can easily calculate the number of values. That means we're going to add all these values divided by the number of values. So we get this mean 93.5. Okay. Then we are going to apply the technique, right? So here the sample population, right? They have given the sample population over here. So what we will do over here, the sample population is given. So we know that we have to use a t-test. So you should know that which formula to use, what to use when sample is given, right? So you will have the x value is given like this. Then you will find x minus x mean. So mean is this. You will find all this value, right? And then you will do the square of this value. You will just do the summation. Now, whenever you have to find the standard deviation, right, for the sample, it is n minus 1. So this is your standard deviation coming out to be, right? Is that clear? So you have used the formula for standard deviation. So you know that this summation you have already find out with, that means 5 to, you can do that in Excel also. It's very easy. And number of sample was 10. So it is 10 minus 1. We always take degree of freedom. That means the actual value. So after this, your this is coming out to be this. So, but what we have to do, we have to find the t-test. So how do we find the t-test? For the t-test, what we have to do is that, as you can see, what is a t-test? This was a t-test. This is what we have to find. Now we have just find out this. We have just find out this thing by using this formula, right? But now we have to find that what is x mean. X mean is already given to us, which is 93.5, which we already find out. What is mu? Mu is already given to us. What is mu is given? Mu is given to us, which is 90. So this is 90, right? Under root n. N is already given to us, 10. This we have already find out. So now this become easy, right? So we can easily do the next part. We can use this formula. So we already know this is the mean. This is the mu, which was given to us. This is what we have calculated. This is under root 10, right? So this is the t calculated value. Now what is the t calculated value? Now t calculated value is coming out to be 0.2499. Now what we have to find? We have to find the t critical value. How do we find the t critical value? With the help of t table. We can find now how you have this t table is available on the internet. So this is a t table. This is how it looks like. So the significance value would be given to you. So based upon this, you can, okay, this is the significance value is given, which is 0.05. And we are using a two-tail test. We know it is a two-tail test because when we write that mu is not equal to 90. So it can be two-tail, right? It can be greater than or less than. And we have the, what is DF? DF is called as degree of freedom. So DF is degree of freedom and it is very important. That means whenever we have been given the actual value, whatever are the sample we have, we are going to subtract 1. So we will get 9. So degree of freedom is 9, right? So this is the actual value that we have, 9. So we cannot, because we are having a sample size. A sample size is always less than the population. So whenever we are going to find out the value of the critical value according to the sample size, we always have to take one value less than the value, the sample size that is given to us. So this is 9. So we will go to the 9 over here. And this is 0.05. And we will find, okay, what is the value coming out to be, right? So this is the t critical value coming out to be 2.262. So calculated value is this, and your alpha is 0.05. So from this you will find 9 and you will find the t critical value. So t critical value is coming out to be 2.2 plus minus 2.262. So now which value is greater? The t critical value is greater than your t calculated value. Or you can also write that if your t critical value is greater, so what we do, we fail to reject the null hypothesis. We fail to reject the null hypothesis, right? So we can say that H0 is equal to 90. This is true, right? This is true. We cannot reject it, right? Because t critical value is greater than the t calculated value. So is the t test clear to everybody? Please. Is the t test clear, everybody? You can write in the chat window if it is clear, the t test, the entire explanation that I've given for the t test. Because as you can say, first of all, we started with that what is a t test? Whenever a sample is given to us, we do a t test, right? So the standard deviation we need to find out, right? For this, we always take the value n of which is n minus 1, right? So I think it's clear. Most of you are writing clear. So now let's go to the next part. Okay, so now we come to the next part, which is the t-test is clear. This is the first method that we did, right? And from this, we found out that whether we are going to reject the null hypothesis or we are going to accept the null hypothesis, right? So it's not mentioned over here. So this was your value which was calculated 2.262, right? Again, I'm explaining. We do we find out that what is the calculated. So we found what is the t calculated. This was done by using the formula. And then with the help of this table, we find out that what is t critical. So this is 2.262. So whenever your t calculated, let's write down, whenever your t calculated value is less than your t critical value, then what we do? We cannot reject the null hypothesis. So we can say we fail to reject the null hypothesis. So this will come into practice when you're going to do a lot of case studies. So you will also understand, because this is very easy thing to remember. The p-value is less than 0.05, we reject the null hypothesis. If p-value is greater than 0.05, we fail to reject the null hypothesis. If t critical value is greater than the t calculated value, we fail to reject the null hypothesis, right? If t critical value is less than the t calculated value, we reject the null hypothesis. So you have to remember these formulas, right? Now we come to the next part of your parametric test, which is your correlation coefficient, Karl-Pearson correlation coefficient. Now this is based on this formula. See, we are going to do the using the same thing. We will be doing R also, R software. So, but let me first explain you that how to understand, because in R it's very simple. You just have to write a line of code and it will be done. But what is the mathematic behind a particular method is what you need to understand in order to understand the parametric testing, right? If you do not understand what is the mathematics behind it, it will be very difficult for you to understand that why do we fail the hypothesis, or why we do not reject the hypothesis. Because when you will be doing by using a R software or by using Python or any other software, you will simply get a value. But when you will be using Excel, or when you'll be doing it manually, you will try to understand the entire procedure, right? Otherwise, when you'll be doing an R, you'll simply writing of a line of code and it will give you a p value. And based upon the p value, it will be deciding that whether it is rejecting or it is not rejecting, right? So this is a second method that we have for the parametric method. So this is a second parametric method that we are doing, which is called as your correlation coefficient, right? Now this is again based on two variables that we have, right? So this is the mean, right? And this is how we are going to find out the R value. Then based upon the R value, we'll be deciding that whether it is having a strong correlation, whether it is having a weak correlation, or whether it is having no correlation. Suppose if your R value is -1, then we can say it is having a strong negative correlation, right? So you will have to find out this value. You can easily find out with the help of when you're writing a code, you can simply write core, and then you can simply write x comma y, and you can write whatever methods is equal to Pearson. So it can easily find out when R is equal to 1. When R is equal to 1, it is having a strong positive correlation. Okay, positive correlation. And when say R is equal to 0, that means there is no correlation. Okay, so we will come to this. Okay, so this is what we have find out. This is the formula which we'll be doing further, right? So whenever you are using the population, now let's say there is one dependent variable, population density, and it is based upon the independent variable. So independent variable could be your economic independent, climatic independent, or geographical independent variable, right? So we have to consider that how the population density is affected by the different variables, right? So null hypothesis, as I always state, null hypothesis means that there is no effect, that there is no significant relationship between, let's say, take an example, between a per capita income and the population. So there is one variable which we have taken out of the multiple variables, which is the economic variable, which is your per capita income. So when in H0 we say that there is no relationship, right? So there is no relationship. H1 say that there is a relationship. It may be a positive, it may be a negative. We do not know. But here we are saying it is 0. It is no relationship. But here saying there is a relationship. It could be a positive, or it could be a strong positive. It could be a strong negative. Like depending upon the value we may get it. It could be also medium positive. It could be a medium negative. It could be a weak negative, weak positive. So that is the different thing. Okay. Now see, this is a very important question. You can do this in Excel. So see, this is the X value given income. This is the density value. This is given, right? So first of all, you will find that what is the mean of X, what is the mean of Y by using a formula. Once you have done this, you can simply find that what is X minus X mean. So you will get the negative value. Now we want the positive value, right? So we will just do the square of this, right? We will get the positive value. We will add this. Again, we will do Y minus Y mean. We want to get the positive value. We will do the square of this. We will get the positive value. Okay. So that means you already did the denominator. You have already done. You got the two values. Now we come to the numerator, which is X minus X mean multiplied by Y minus Y mean. You did this, right? and you get this value. This is going to take not a lot of time when you're going to do in Excel, right? So then we have to use this formula, right? We will be writing this value and we will get R is equal to minus 0.945. So that means we are getting a negative value. So since we are getting a negative value, that means it is having a correlation. It is having a negative correlation. So we are going to reject the null hypothesis. That means there is a significant correlation between the two values. So that means it may be if it is negative or positive, but there is a correlation. So therefore, we are going to say that our output will be there is a significant, because at zero say that there is no significant, but we can say there is some significant relationship between the income and the population density in urban areas. Okay, so this is your output. This is what you have proved, because you have rejected at zero, which was saying that there is no significant relationship, but you're saying that there is a significant relationship and you have rejected the null hypothesis. Okay, now let's come to the first part is done. The parametric methods is done. Now our focus will be just on the non-parametric methods. We are going to do the chi-square methods. We are going to do the Spearman correlation method, right? And the Kruskal-Wallis method is just same as the ANOVA method. And then we are going to do in detail the Kendall's method. So we are going to do these four methods in detail now, right? Yeah, chi-square test, Spearman correlation test, and Kendall test. And we will be using R also to show the output of the Spearman correlation test and the Kendall test, right? Which is very easy to see, but we have to understand that what is a chi-square test, what is a Spearman correlation test, because now we are talking about non-parametric test, which basically is distribution free test, which do not depend upon any distribution. A distribution could be positively skewed, it could be negatively skewed. So, and it is based on the nominal data, right? And the ordinal data. Okay. So now just tell me, are the parametric tests clear to everybody? Are the parametric tests clear to everyone? Please reply. Okay, that's great. Okay, let me ask you some questions, and I just want to answer you to answer that in the chat window, right? I'll just take 5 minutes for that. You can write your answers, right? Okay, just tell me that what decision is made if the calculated test statistic is greater than a critical value. If your calculated test statistic is greater than the critical value, then what decision is made? I repeat, if your calculated test statistic is, yes, very good, except the alternative hypothesis. And what else we can say? We reject the null hypothesis, right? So we can say we reject the null hypothesis if your test statistic calculated value is greater than the critical value. Very good, 100%. Okay, what is a type 1 error? What do you mean by type 1 error? When I say a type 1 error, that means, what does that mean? No, no. You reject the null hypothesis while it is true. Yes, yes. That means you are rejecting it, but it is true. So that is a type 1 error. Yes, it is false positive. Absolutely right. So this will come when you are going to read more about it. It will be more clear to you. So reading will make you perfect when you'll be reading more about this. And you can, there are so many blogs which I've already written. If you just go to the EU student launch, I have already given a very good blog about the hypothesis testing over here. And I'll be sharing a blog on parametric and non-parametric also. So you can just, it's better to read the blogs, in that way we share the blogs for you also, where you can put your ideas and you can also interact with each other, where I can also, give you feedback about your understanding. So that's the reason we have, but you people, I've written blog, I mean, almost like 2 months back, but there was no feedback on that. So I would just want you to go and just read the blog on this hypothesis testing. Okay. So one more question and we'll go back to the non-parametric method, okay? You go to EU student launch and there under your announcement, there is the blog. So you can find it when I think you're a new student. So in EU student launch, there is an announcement section for the MS Data Science student, and there you can find out the blog. Okay, what do you mean by the significance level? This is also important. What do you mean by significance level? That is alpha. Why do we have alpha? What does that mean? Anyone? Alpha is not the confidence interval, but we can say that if we have alpha, we can easily find out the confidence interval. Yes, it is 0.05. So it's a threshold. What is alpha? It is a threshold, which is deciding that whether we have to reject the null hypothesis. So any value that is coming within the threshold, that means we will be, yeah, it is 0.05. Yeah, 5%, but 0.05 is the value. Okay. So it is a threshold which basically decides that whether we are going to reject the null hypothesis or not. Okay. Okay. One more thing. Yeah, the probability of making a type 1 error. Okay. Yes. Now tell me, suppose we have the standard deviation of a sample given and their sample size is also very small. What kind of test we should go for? If your sample standard deviation is given and we have the sample size is also very small. What kind of test? Yes, t-test. Absolutely right. T-test. 100%. Very good. Very good. Absolutely right. Okay. That's great. So now let's come back to the non-parametric method, right? Okay. Non-parametric test. Now it's very important to know about what is non-parametric test. No, Z-test is only being done when you have been given the population standard deviation. So if you will do only population standard deviation is given, then you will go for your Z-test. But if your sample standard deviation is given, you will go for your T-test. Okay. So now we come to the non-parametric test, right? So it do not depend upon any distribution and it is applicable to the nominal and the ordinal data. So the advantage is that it is done on the small size, so sample size. It is done on the categorical data, which is the ordinal data, and it is not, the data is not normally distributed. So it can be a positively skewed data or a negatively skewed data, or it could be a bimodal data. So and most of the time your real data is always always go for your free distribution, because whenever we have a real data set, we cannot have a normal distribution like this. This is not possible for the real data, right? So that is why most of the time we have to go for the non-parametric test when we're talking about the real data, or when we have the qualitative variables, and even when we have the quantitative variables, we have to convert them into the parametric test variables by using ranking. So I will tell you how do we do a rank correlation test over here. Okay, so these are the tests, the chi-square test. So this is depending upon the category. So there is an observed category and there's expected category. Spearman correlation test we'll be doing, which is again a rank order test. Mann-Whitney U test, Wilcoxon test, and Kruskal-Wallis. So this all is similar to the ANOVA test that we have done. If you will see in my last, you can also go and watch the last boot camp that we did. So there we did your Kruskal-Wallis test. Uh, we did the because there we started with the statistic part, and we also did the ANOVA test, right? So you can see over there. So that is why I'm not covering it over here this time, right? So let's come to the chi-square test. Now chi-square test is again we have to find that what is this value. So based upon this value, we actually identify, right? So this is the observed value and this is the expected value. So you have to know that this is used whenever we have to identify that whatever is the observed value minus the expected value divided by the expected value. This is given to us. This is always given to us, and based upon that we have to find out that what is your this value and what is this EIJ. That means it is also used to calculate based upon your column total and your row total, right? What is your column total and your row total? So it is written as your row total into your column total divided by your. Yes, I will be sharing the presentation, 100%. Row total into the column total divided by all the values. That means whatever is the total, right? Oh, sorry. I just, yeah, I'm doing it. Thank you. Just forgot to share the screen again. Okay, now you all can see. So this is your chi-square test. Okay. Okay, so this was a chi-square test. So this is the observed value. This is the expected value. And how do we find the expected value? We can also use a matrix to find the expected value. This is your row total. You can write the formula into column total divided by the total number of values, right? So this is how you have to find the expected value, right? Of the cell in the ith row and the jth column. And this is the observed value of the cell in the ith row and the jth column. So you'll understand much better when I'm going to give you a case study. Now see, this is the water connection in the slum, right? This is the value. This is the slum no connection, right? This is non-slum water connection, non-slum no connection. This is a total value. And this is the total value for having the water connection. And this is the total value for having the no connection, right? So in this, first of all, you have to find out that what is the chi-square value. And based on this, first of all, you will find the calculated value, which you will find by using the formula. And then you will find the critical value. Then you will find the chi-square critical value. And based upon this chi-square calculated value and the critical value, you have to identify that suppose your if calculated value is less than your critical value, right? Then what you're going to do is that if your calculated value is, then you are going to do not reject the null hypothesis. right? But if your calculated value is greater than your critical value, then you reject the null hypothesis. Okay, so this is what we are going to do in this particular test. We will be using this formula to find out the calculated value, and then we will find out the critical value as well. Okay. Okay, now this is very simple now. What is a null hypothesis? Null hypothesis means that we are having, this is the settlement type. Over here, slums and non-slums, and here these are the water connection. So we are saying the settlement type do not have any relationship with the water connection, or do not have any impact, you know. So that means it is having no relationship, or they are not dependent. So we can say these are independent. So your null hypothesis means these are independent of each other. There is no effect of both of these, settlement and the water connection. The alternate hypothesis saying that they are not independent. So it is opposite always. Your alternate is always opposite. It's saying that they are not independent, right? So this is again, we have, what is this? This is the observed value that we are having. Based on this, we are going to find out the expected value. Again, the same thing, have water connection. Here it will be no connection. Here it will be total. And here it will be slum. So this is actually a long calculation, but definitely it is very easy. You just have to know the formulas and it will be very easy for you to do, right? Now expected value is coming is what? Row total into column total divided by your grand total. So what is a row total over here? What is a row total? Suppose for the first value which I have, right? What is the row total? It is coming out to be 55 into the column total is also 55 divided by the total number, right? So 55 into 55, what is the grand total? 100. Okay. Again, for the next, row total into column total. So what is the row total over here? For this no connection, the row total is again coming out to be 55. Column total is 45. So 55 into 45 divided by 100. Okay. Now here it is saying for the non-slum, what is the row total? It is 45. Column total is 55. So 45 into 55 divided by 100. And here it is 45 into 45 divided by 100. Okay. So if you're going to find this value, you will be finding out that what is the observed value and the expected value, right? So let's go. Okay, see. So they have found out the values. You can see the values that they have calculated. That means 55, that means row total and column total. So this is 30.25. And this is again, this is what is the row total? The row total is 55, column total is 45. So this is come out 24.75. And if you add this come out to be 55 only, right? So this is 24. So this is all the values that we have for the expected value. So we have found the metrics for the observed value OIJ, and we have metrics for the expected value, which is EIJ. Now what we have to do? Now we have to use this OIJ minus EIJ. That means whatever is the value coming over here, we will be making one more matrix. We will be doing 25 minus 30.25. 30 minus 24.75. 30 minus this, 15 minus this. So our final matrix will be like this, right? So this is 25 minus this. And then what we are going to do? We are going to do a square of this, right? So when we are going to do a square of this, we are going to do a square. So all the negative values will be gone. So this will be the final value that we will be having, right? Okay. So what they have done is that they have just find out the final answer. Okay. So let me just make it over here. The steps after this is that they have find out this, then they have done the square of this. So let's say the square of this come out to be 27 something. This is also be 27 something. This is also 27, right? So they have done the square of this, right? And they know what is EIJ. EIJ is already they have calculated, which was this, right? Which is this. EIJ is this. 30, 24, 25. So this value they have already calculated this. Now they have to make a final matrix. So how do they have to find the final matrix? That means it is your OIJ minus EIJ whole square, right? Divided by EIJ. So that means you have to calculate this value. So these all four values that you get, you are going to add this value, right? And you are going to divide it by the final value of EIJ. So based upon that, your final value will be this. Because if you're going to add all this, it is coming to be 4.5, right? So your x square calculator is going to be 4.5. Okay. Next is you are going to calculate the degree of freedom. Degree of freedom will be calculated as column -1 into row -1. Column are 2, rows are 2. So degree of freedom is 1. Then we are going to use this table, a chi-square distribution table. We know that your critical value will be 0.05 and 1. So we will be using 3.841. So 3.841 is your critical value and this is your calculated value. So from this, you know 4.5 is greater than this. So hence your x calculated value, x square calculated value or chi-square calculated value is greater than chi-square critical value. So we reject the null hypothesis. When we reject the null hypothesis, we say that yes, there is a significant relationship between the settlement type and the water connection. So let me just quickly go back to the first part and just revise it for you because it's a long calculations. Okay. So see what is chi-square? The observed value is given to you. You have find out what is the expected value by using the formula of row total into column total divided by the total value. This is given to you. This is already given to you. You already have this. So you from this you know that this metric is given to you. So you know that the total values that you have is 100. This is a total value. And based on this you calculated, you find out null hypothesis means that this is the settlement type and the corrections are independent. And the alternate was that they are not independent. Then based on that, you calculated the expected value. Expected value is always based on the row total and column total, right? And divided by the total. So based on this, the expected value came out to be 30.25 for the slums and have water connection and 24.75 for the slums and no connection. Similarly, for non-slums and water connection, the value was 24.75 and for non-slums and no connection, the value was 20.25. So this was done. Now you have your expected value and you have your observed value. Now you are going to use the formula, which is you see this is they have written this is observed value, expected value, observed value, expected value. So they have written this in your one matrix. Now you have OIJ minus EIJ. That means now you are going to subtract this. You will get this, right? You are going to subtract your OIJ minus EIJ whole square. Now you will be doing the whole square. That means you are going to find the square of all the four values over here, right? And after finding the whole square, this they have actually not done. So you will get something like that, right? And your EIJ is also given, right? What is the EIJ that was given? This was 30.25. This was 24.75. This was 24.75 and this is 20.25. So this is the E value that is given and this is your OIJ minus EIJ whole square is given, right? Now what you have to do, you simply have to divide this by this. That means 27 point something divided by 30.25. So when you will divide 27.25 divided by 30.25, you will get this 0.9111. Then you will again divide this 27 this by 24.75. You will get this value 1.114. Again, you will divide this 27 by 24. The same value will come here, which is 1.114. And you will divide this 27 divided by 20.25. You will get the value 1.361. So this is your final matrix. This is the final matrix that you have calculated. Now what you have to do, after doing all this, you want to have the summation. So you will add all these four values and that will be your calculated chi-square that you have found. So this is how you get the calculated chi-square. After getting the calculated chi-square, after getting a calculated chi-square, you also have to find the critical value. Now critical value, you always have to find the DF over here, right? And then you have to do your significance, which is 0.05 given. So DF is calculated by using column -1 into row -1. This is a formula for the non-parametric. For the parametric, it was n-1 simply. But here we are using in a form of metric. So it is column -1 into row -1. So therefore it is 1. And based on that, we actually got from 1.05, we get this value. So this value is less than the calculated value. So whenever we say that your X critical value is less than your X, this chi-square critical value is less than your chi-square calculated value. So we reject the null hypothesis, right? So hence we can say that there is a relationship. So I hope the chi-square test is clear to everybody. Please write down in the chat window if it is clear. The chi-square test is clear, the non-parametric test. This is the first non-parametric test we have done. We will be doing the next two, which is your Spearman correlation test, and then we'll be doing the candle test. The two more tests we are going to do. So is it clear? Okay. Yes, multiple rows and columns can also be analyzed by using this. You can find more questions, right? Based on this, you can go to the lecture, you can study the lecture. I'll be also sharing this and some more examples. So you can see over there. Your metrics can be 4 to 4, it can be 6 to 6. You can do it. Okay. So the next test we are going to do over here is your Spearman rank correlation test. So this is again based on a very simple formula in which you have to find the rank. So this is a rank test. Again, this is a rank test, a correlation test. Here, whatever data is given to you, you have to find the rank of the data, right? And based upon that rank, you have to identify that whether it's having a correlation or whether it is not having a correlation, right? So this is again a very important test for your non-parametric method. So here we can also specify the null hypothesis and the alternate hypothesis. See, it is a Spearman correlation which we actually find out. This is a difference in the rank, right? Which I'll tell you how to find out. This is the number of the sample, the number of observation, right? So when we say it is equal to 1, we say that there is a monotonic, means continuously there is an increasing relationship. Monotonic increasing means continuously the relationship is increasing, right? Between the two variables. When we say it is -1, that means it is the monotonic decreasing, like continuously it is decreasing. And when we say it is equal to 0, that means there is no relationship. So whenever we write null hypothesis, we always assume this one, that there is no relationship. There is no monotonic relationship between the two variables. But your alternate hypothesis is based on this two part. That means there is a monotonic relationship between two variables. It may be a positive relationship or it could be a negative relationship, but there is a relationship. or there, but if we say when there it is no, then we do it is called as null hypothesis. So this is a Spearman correlation example. This is a building, right? So there are 5 buildings over here and the height is given and their historical significance is given, right? So now what we have to do is we have to, this height is given in meter. We have to just arrange it in the form of like a rank. So this is having the first rank, 25. Next, this is having the second rank. This is having the third rank, fourth rank, and fifth rank. This is already given in form of ranks, the historical significance. But this building, it is so we will be putting it in a form of rank. So after we have done this, we are going to uh, okay. This is 18. So null hypothesis state that there is no monotonic relationship. As I told you, there is no monotonic relationship between the building height and the historical significance. And the alternate hypothesis says that there is a monotonic relationship between the height and the historical significance. So this is very simple. I told you that we are going to arrange this into a, this is 1, this is 2, this is 3, this is 4, this is 5. So again, we are going to write 3, 4, 5, 1, 2. This is the range of the rank of the building. This is a historical significance rank. It is already given. So next what we are going to do is we are going to find out that what is DI's, what is the difference of the rank. So here it is -1, here it is 2, here it is 0, 0, and here it is -1. Next, what we are going to do, we are going to add all these values, right? That what we are going to do, we are going to do summation of DI whole square. So there we'll get 1 plus 4 plus 1, we get 6 value over here, right? Next, we are going to do is we are going to find the this formula, which is the formula is what it is. I'll just rub this one. So what is the formula? The formula is 1 minus 6 summation of d square, which is 6. What is n? N is 5. There are 5 values. So it is 1 minus 6 into 6 divided by 5, and it is coming out to be 24, right? So when you will do this value, what is the value coming? 0.700. So the value is coming out to be 0.700. Now you have to find out the critical value. Okay, now this is, they have left it over here. Now what you can do is you can find a critical value. So you can basically take n is equal to 5, and for your this significance level, your alpha is 0.05. So by using a Spearman correlation table, you can find what is the value over here for n is equal to 5 and for significance value. Now whatever is this value that is coming, that is called as your P critical. And if this critical value is, let's say, now if this calculated value is greater than the critical value, we say we fail to reject the null hypothesis. But if this critical value is having the greater than this value, we say we reject the null hypothesis. So you can see this by finding out the critical value. The critical value they have not find out over here, but you can check that how you reject it. Suppose if this value is coming out to be greater than the critical value, then you fail to reject the null hypothesis, right? So when you fail to reject the null hypothesis, then what is true? Can anybody tell me? When in this condition, I fail to, let's say I fail to reject the null hypothesis. So what will be the output? How you're going to write the output? Please. When I'm saying over here that I fail to reject the null hypothesis, what will be the output? How I'm going to interpret the result? Anybody can tell me? This is very easy. When I'm failing to reject the null hypothesis, that means I'm accepting the null hypothesis. And what does the null hypothesis says? The null hypothesis says that there is no monotonic relationship between the building height and the historical significance. So that means this is we are accepting it. So we are saying that we fail to reject the null hypothesis. So when we fail to reject the null hypothesis, what does it signify? It signifies that, just a moment. It signifies that there is no monotonic relationship between the historical significance and the building height. So this is true. This is accepted. We are failing to reject the null hypothesis means that we have find out based on this Spearman correlation, whatever is the calculated value that we got, it was greater than the critical value. So there is no significance. So this is, we should know that what is our finding, why we are doing this, why we are doing this, why we are getting the critical value, what is the significance? Because we want to find out whether we are rejecting it or whether we are not rejecting it. So when we are saying we do not reject, that means there is no relationship. There is no relationship between the height of the building and the historical significance. Okay. So you should always know your output, that this was the output. Okay. So now we will simply do a revision of what we did, right? So I hope these are the techniques that we have proposed. So I think one more method is left, I told you. So parameter, it's a characteristic of a population. You should know these terms. These are very important. That what is a parameter? It is a characteristic of the population. And whenever we say sample, what is a sample? A sample is a subset. It's a subset of the population. So whenever we say sample, it is called as a subset of the population, right? So a subset of statistical, these terms are very important for you, right? In any examination that you're given, you should be able to understand these topics. They've been asked in MCQs as well, and as well in interviews as well. There was a difference between a population and sample. What is a parameter? Parameter is the significance of a population. What is statistic? A statistic is the significance of a sample, right? So inference, what is inference? Inference means that whenever the inference is related to the population, we say a parameter. Whenever the inference is related to the sample mean, we say an estimate, right? So I'll go forward with these terms, technical term. So there are basically two assumptions that we do. First is your estimation and test of hypothesis, right? Parametric inference means that when we are actually making assumptions about the population. So that is, and statistic is when we are making an assumption about a sample. Okay, so this is what this is a Gaussian, or we can say it is a normal distribution curve, right? But whereas when we talk about the real time, this is actually how your data looks like. A bimodal, a positive skewed, a negative skewed. So this is what your population looks like in real. So whenever your population is having the less number of sample, we cannot do your CLT, the central limit theorem is not done, right? Then we come the non-parametric inference. So population is continuous. Continuous, you understand? That means it is it can be counted. When or we can say continuous means like height is continuous. We can have a height between 6 to 7, like 6.7 can be there, 6.6 can be there. But anything which is discrete, that means we cannot divide that into parts. That is, but population is continuous, right? So non-parametric methods are used most of the time because of their generality, because they are also perform well with the outliers also, right? They are quick and easy to apply, and they are distribution free. So this is all we have done. H0, H1, hypothesis, how to do a hypothesis testing, right? So whenever we write H0 is this, and when we say H1 is not equal, so it can be greater than, it can be less than. So it always become a two-tailed test, right? But even if it is only greater, then it become a one-sided test. It should be greater than or less than. So we know what is a critical region, what is which is also a rejection region, what is the acceptance region. We studied about that, right? We already done this. Just a revision of what we have done. That means when you reject the null hypothesis, it is true. This is just they have written in different way. Is the same thing. Type 1 error. This is your false positive, right? So when you do not reject the null hypothesis, it is false. So this is your false negative, right? And the other is your true negative and your true positive, right? So the significance level, the probability of type 1 error and type 2 error. just the revision. So see, again, this is what, as I told you that the Gaussian or your normal distribution, they are used for value. Suppose if your HA is not equal to. So when I say HA is not equal to, we always use the two-tail test. So what is the two-tail test? That means it can be less than equal to or it can be greater than equal to. So we have alpha. This is a rejection reason. This is a two-tail test, right? When HA is greater than 10. So this is your, when it is greater than, it is your one tail test, right? When we only use only one side. And whenever it is less than, again, it is a one tail test over here, right? So this you can see. Now, non-parametric techniques is recommended whenever we do not have any particular distribution, right? So again, a difference. So in parametric, we basically have the normal distribution. Here we do not have any distribution, normal distribution. It is based on interval and ratio data. It is based on nominal data, right? Here it is based on mean. Here it is based on median. So because it is, because mean means we all already know the mean is the value. But here, if we take mean, it may give us wrong results. There are assumptions already made. There are no strict assumptions in non-parametric method, right? Okay. Now, how to do a ranking? Ranking is very important for you to understand. Suppose this value is given to you, this data is given to you. You have to put it in the ascending order, and then you have to rank it. Similarly, if a data is given to you where there is a tie, tie means the same value is given. So there you can easily find out the value 3 plus 4 plus 5 because 3 is coming in the third position also, in the fourth position also, in the fifth position also, right? Similarly, so these four, the output that will be giving will be 1, and this will be the second. -1 is the first rank, 0 is the second rank, 3 is at 4, 4, 4, all the three. Then 5 and 5, again, this is a tie. So this is like 3, 4, 5. This will be again at 6 and 7. So this will be your 6.5, 6.5, and the rest is 8 and 9. Okay, this is how you have to do the ranking. So in R also, we have used simply to rank the data, right? So this is a collection. You can use that in R, right? And you can also sort the data. You can sort the data in an increasing order, right? And simply if you want to do it in the decreasing order, and you can find out the average. So you will get the same result as we got it from here. The same output you will get when you'll be doing it in R, right? So simply they have taken the value and this they have sorted the data, right? And you can use tie dot method is equal to average. You can also use maximum and you can also use minimum method, right? And based upon that, you may get the output, right? So you should know that how to use the same thing in R. So this should be known to you. Okay. So let's move forward. Okay, now again, when we have a value like 1, 2, 3, and you have to find that what is the permutation of this. So this will be 3 into 2 into 1. So there are 6 ways which you can arrange this value. This is the natural permutation, and these are the other permutation that you have, right? So permutation and reverse permutation. So you should know, sometimes it is asked that what is the inverse permutation, like 3, 1, 2. Now element 3 is in the first position. So now element 3 is in the first position. So its inverse permutation is 1 place in the third position. So element 3 is in the first position. So 1 will be placed in the third position. Element 1 is in the second position. So second will be placed in the first position. Now element 2 is in the third position. So 3 will be placed in the second position. Similarly, you can easily find out. Now what we can say, 2 is placed in the 1 position. So 1 will be placed in the 2 position, right? 3 is in the second position. So 2 will be placed in the third position. Fourth is in the third position. So 3 will be placed in the fourth position. And 1 is in the fifth position. So 5th will be placed. So this is the inverse permutation. So you should also know that what is the inverse permutation. This is many times it has been asked. Okay. So we already done what is the permutation probability. Okay, this is a Spearman correlation test. We have already done this. by using the formula, right? So we already know that this is the formula for the Spearman correlation test, and it could be negative value, it could be a positive value, or it could be a no association, right? So here it is positive monotonic, here it is negative monotonic, and there is non-monotonic. So this is the value that is given to you, right? These are the two values of the judges, and these are the competitors. There are 12 competitors, and they're different ranking given by the different judges, judge A and judge B. So we will use a shortcut method for this. What is the shortcut method is that we are going to first of all uh, just put the value over here. That means we are going to put it side by side, 5, 10, 1, 5. Then we are going to do the subtraction of the ranking, which you already know. We will subtract the ranking. Then we will do di whole square. We will do the square of this, and we will find this value come out to be 84. Then we will use the formula. N is this is your 12. So this is coming out to be 0.70. So that means there is a positive correlation. So when you say this, you have to find this means that there is a positive correlation between the two values, right? So this is again one value. So if I can also do it in R for you to understand. So let me just do it. I'll do it the same problem in R software so that you can understand it more better. Okay. Okay. So any problem till now? Any problem till now? Please let me know. Let me use our compiler. Can you see my screen, everybody? Let me use with the keyboard. It's not working. Okay, let me just do the. It will be very long if we just keep on writing. Can you see the screen, everyone? All of you, can you see the screen? Yes. Okay. So you can see the same problem that we did. We are doing it with the help of the R. So we have taken the collection. This is the value that we have given. We have sorted the data, and then we have found out that with the method of average. So this is what we are getting in the output, right? Similarly, let's do a Spearman correlation test. So what we are going to do over here is we are going to take X1 and Y1. X1 will be having some value, Y1 will be having some value. First of all, we are going to find the correlation between X1 and Y1, right? This is the first thing that we are going to do. So I have already written the code for you because if you're going to write it, it's going to take a lot of time. So this is a correlation, right? So that means whenever we are doing a correlation between X and 5, we can say that they are correlated. Now we have to find what is the p-value. Okay. So this will be a alternative two-sided test. So we will use core.test. XY method will be Spearman. So this is what we have done in manually. We did the long calculation, but here it is just very simple. You just have to write the name of the method and alternative, whether it's a two-sided test, whether it's a one-sided test, and you can simply run it. So you get your p-value. See, This is what the first thing that you get, which was your correlation, your the Spearman correlation. Then your value S is coming out to be 87.65. The P value is coming out to be 0.01, right? So that means this value is coming out to be this. And based upon that, you can say that your rho value is this, right? So this means your P value is 0.01237. Okay. So alternate hypothesis is true. Rho is not equal to 0. Okay. So your rho value is not equal to 0 and your alternate hypothesis is true. Now let's take one more method over here. Similarly, we can do for other methods also. We just have to write the name of the method and it's very simple. Now this is one more example over here. If you're going to do it manually, it is going to take a lot of time. Now what this example state, here there are two values was given, x1 and y1, both were the quantitative data, right? So what we did was that first of all, we changed that data uh, into rank. So we did the rank for both the methods. That means for x1 and y1, right? And let me see what the output is coming out to be. So in the first method that we did, uh, we actually accepted the null hypothesis in the previous method. And here what the rho value, p value is going to be 0.7131, right? So here we cannot reject the null hypothesis. Okay. So we do not reject the null hypothesis because this value is coming out to be greater than 0.05. So p value is coming to be greater than 0.05. So we say we do not reject the null hypothesis. So this is very simple. You can easily write the code. You can take the data, you can write the methods, and you can simply get your results. Okay. So let me just go back to the slide. So similarly, you can write in R also. I've done this in R over here, but now I just want, it is going to take a lot of time. So you simply have, what you have to do over here is, let me just show you. So see, you have written x1 value, you have written y1 value. Then you have written correlation of x1 and y1. And then you have written the correlation value. So based upon this, first you will get the correlation value, whether it is positively correlated, and there you will get a p value. So based upon this, if your p value is less than 0.05, you reject the null hypothesis. But if your p value, let's say if your p value is something like 0.1731, so this is greater than 0.05, so you do not reject the null hypothesis. Okay, so this is how you have to do in your R. So this is your script area. Here you write script. This is the console where you get the output, right? This is where your plots will come. Even when you're putting plots, this will come, right? And these are where your variables will be defined, right? So this is divided into 4 parts. This R is also very simple. So similarly over here, you have written your x1 value, y1 value, which method you use, and you test the correlation to find out the p value. Similarly, this is a different example. So again, the x1, x2 value, right? And you have done the Spearman correlation. Now we come to the last part, which is your Kendall's rank correlation. This is also a part of your uh, non-parametric test. It's a very important test. And it is also a non-parametric test. Here you find a correlation again. So just try to understand that what it is. So this is again a rank-based test, right? It is based on two type of pair. One, it is your concordant pair and other is your discordant pair. So what is a concordant pair and what is a discordant pair? Suppose a value x1 is given to you. A value x1 is greater than x2 and a value y1 is greater than y2. Suppose x1 is greater than x2 and y1 is greater than y2, or if x1 is less than x2 and y1 is less than y2, then this pair is called as your concordant pair, right? So for this value, your value will be concordant. But if it is opposite, now suppose let's say you take x1 and y1, right? Your x1, y1 is 25 and 14, and your x2, y2 is coming out to be 8 and 12. So you know that x1 is greater than x2. This is correct. And your y1 is greater than y2. This is also correct. So this pair is called as your concordant pair. Okay. Now we come to a discordant pair. Discordant pair means opposite. Your x1 is greater than x2 and your y1 is less than y2, right? So this is opposite, right? Now again, we take one more example where x1, y1 is coming out to be, let's say, here we have 25 and here we have 14. And here x2 and y2, this is like 8 and this is 20, let's say. Now what we in this, your x1 is greater than x2. This is correct, right? But your y1 is less than y2. So this pair is called as your discordant pair, right? So whenever we do a Kendall's t-test, we take the number of concordant pair minus the number of discordant pair. And this is how we find out the t value, right? It also find out what is a monotonic relationship, whether it's a perfect monotonic, it's perfect, or there is no relationship. So again, t is equal to 1 or t is equal to -1 or whether t is equal to 0. So these are the three things which we find out. So again, we take a number of comparison is n upon n into n minus 1 divided by 2. So this is again for the total number of comparison. So now again, we have the last this um, case study with us. This is the competitor. Excuse me. Yeah, excuse me. So this is the competitor, that 12 competitor, same problem that we did in Spearman correlation, we are doing over here. Judge A and Judge B, right? So see, what we are going to do over here is we have the value of Judge A, the rank the Judge A has given, and the rank Judge B is given, right? So how many checks we have to do? Sorry. The checks that we have to do is n into n minus 1 divided by 2. So the value is 12 into 11 divided by 2. So it's come out to be 121 by 2. So these are the number of checks that we have to do. So here we are going to use a shortcut method. What does a shortcut method means? A shortcut method means that you have to write the rank of Judge A in the ascending order, which is very easy. And then you have to write the corresponding rank of Judge B, which is correspond to that rank. So what we are going to do over here is, let me make it simply one more slide. I'll make it because this is very difficult to understand. Okay. So what I'm going to do over here is I'm going to create a rank. That means I'm going to write Judge A and I'll be putting the rank in the increasing order. So I know there are 12 and Judge B, I'm going to write the same rank. So Judge B 1 was getting a rank 5. 2 was getting a rank 2. Right? So Judge A, I'm writing the rank in the increasing order, and Judge B, I'm going to write the corresponding rank of the Judge B. So it was rank 2. For 3, 4. For 4, the rank was, okay, I'll see from here, the rank was 1. For 5, 10, 7. For 5, the rank was 10 given by Judge B, or those Judge A is given 5. For 6, he has given 7. And for 7, he has given 3. For those judge A has given 7, he has given 3. For 8, he has given 6. For 9th rank, he has given the 11th rank to the same person. For the 10th rank, he has given the 8th rank. For the 11th rank, he has given the 9th rank. 11th, he has given 9, and 12, both of them are given 12th person, the 12th rank only. So he has given 9 and 12. Okay. So now what we are going to do is we have to find that what are the concordant. We have to calculate the score. Now this score is what? I know 1 is less than 2, 2 is less than 3, 3 is less than 4. But here the values will be differ. So we can say 5 is greater than 2. 5 is greater than 2. So we will give it a value of -1. Now 5 is greater than 4. Again, we'll give a value of -1. 5 is greater than 1, -1. 5 is less than 10, +1. 5 is less than, again it will be +1. 5 is greater than, it will be -1, right? It is discordant. And here it is +1. It will be +1 for the rest. +1, +1, +1, +1, right? Similarly, now we will not take 5, we will take 2. 2 is less than 4 +1. 2 is greater than 1 -1. For rest all it is +1, +1, +1. So I hope you understand how we have to do this. Again, we will take for 4. 4 is greater than 1. So it is coming out to be -1. For the rest, it is +1, +1. 4 is greater than 3. It is -1. For the rest, it is +1, +1, +1, like this. For 1, 1 is always less than all these values. So it will always be +1, +1. But we are not going to compare the previous value. We are just going to compare the value which is down, right? So this all is done. Similarly, they find the value 3. Add all this. 3 is coming. This 8 is coming. 5, 8 minus 3, 2, 5, right? So when they are going to add all this value, when they are going to add all this score, they get a value of 34, right? Then they divided by, because what was the formula? The formula that was that whatever is the total score divided, that means whatever is the concordant value minus the discordant value divided by the total number, n minus 1 divided by 2. So this is coming out to be 0.5151, right? So that means there is a monotonic relationship between the two x and y value, right? So that means there is a monotonic relationship. So this is again one more example. Here they have the minutes between the rest period. 10 randomly chosen male college students are used in an experiment to investigate the claim that physical strength decreases with fatigue. Describe the relationship for the data below using both. So you have to use both the Spearmint test. You can do this, right? You can do this yourself. So this is again the minutes between the rest period, and this is pound lifted per minute. So this is again, you have to see that what method you have to use, right? So this is equal to 0 and whether it is less than 0. Again, population spearmint rank correlation, say it is equal to 0. It is. Now, why it is saying less? Why less than is used over here? Because you can say it decreases. So you have to see what is written in the problem. If the problem is saying it is not equal, so you will simply put a value of not equal to over here. Not equal to, that's it. But here it is saying it is decreasing. So therefore, you have to put a value of less than. So I hope it is very important for you to read the entire um, problem first, then to identify that what you are actually getting. So again, you have x1, y1 value. In the place of spearmint, you have to just put the candle, and alternative is two-sided over here, right? Then based upon this, you will get the value of your p-value. So whatever is the p-value, if it is less than 0.05, you're going to reject the null hypothesis. And if the value is coming out to be greater, right? So here you can say, see, the value is coming out to be greater. So when the value is coming out to be greater, then what you can do is, okay, where we were? When the value is coming out to be greater, so that means you do not reject the null hypothesis. So you accept the null hypothesis. So that means there is a relationship between the two values. So this was all about the parametric and the non-parametric test that we have done. So let me do a revision of what we did. So in the first part, we did that what is the hypothesis testing. So explained you what is hypothesis testing. Then we did the basically what is the H1 and what is the H0. How do we put the hypothesis? Then we did that there are two types of checks that we do for hypothesis testing. One is your p-value and another is your critical value. So you have to identify that what is the value of p-value. If it is less than 0.05, then you actually reject the null hypothesis. And if your t critical value is less than your t calculated value, then you reject the null hypothesis. Otherwise, you do not reject the null hypothesis. Then also we find out that what is the what was the confusion matrix. In the confusion matrix, we actually find out that when we are rejecting the null hypothesis, and it is true. So we say it is a type 1 error, right? And again, when we are do not rejecting the null hypothesis, it is false. It is a type 2 error, right? Then we went to the parametric test. In the parametric test, we did what is a t-test, what is a z-test. The formula is just the same for the t-test and the z-test. The only difference is that in the z-test, we have been given the population standard deviation, whereas in a t-test, we have been given a sample standard deviation. Otherwise, it is just exactly the same, both the t-test and the z-test. Then we did the Pearson correlation coefficient test. For this, we also find out that what is the p-value and what is the critical value. Then in the non-parametric test, we did first of all that what is the chi-square test. Then we did the Spearman correlation test, and finally we did the Kendall test, right? Which is the final test that we did. I will just write down the name of all the tests for the parametric and the non-parametric. So we did the Z test over here. You can just, revision. If you'll do the revision, then only you will be able to, get it. Otherwise, you will forget it after some time. So better you revise it. Read the blogs, as I've told you that I've shared the blog. When you go to your student launch, there in the announcement section, I have written a blog. So you just read it, understand what is hypothesis testing, what is null hypothesis, right? So then only you will understand it more better. Okay. So what is type 1 error? What is Gaussian? You should all know all these things, right? What is permutation? Though we don't have to do a lot of permutation over here, but at least you should know. For the non-parametric test, other test also I've done the ANOVA test, I've done linear regression, we have already done. You should know what is linear regression, what is multiple. This is very important. Then we did the I will try to, there are other methods also which we couldn't talk about just based on the time constraint. But when I'll be giving you the slide, I will be putting all the methods in that so that you can understand and you can read about all the methods for non-parametric, because when you're doing a research, you have to see that which method is apt for your data. And based on that, you have to apply that method. So I think I have completed the lecture, right, on the non-parametric and the parametric methods. And I hope you would have understand that why these two things are very essential for your research. And if you have any question, you can ask me. Or any feedback that you want to give, you can give. Or if you're fine, we can just wind up the lecture and we can meet next time for the next topic. You can suggest me the topic also if you want. Any issue coming up, you can just let me know. Or if you're good, uh, okay, thank you. Thank you for being there. Yes, you have to revise, you have to go through it. And once you revise it, definitely it's very easy. You just have to remember some of the formulas, right? And while you're using R or any other software, you just have to simply write the line of codes. But what is going behind that logic? That is the reason I have given you the manual case studies, because you should know what is going behind the logic when you're getting the results. Thank you. You're most welcome. So I think we're all done, and I'm going to end the session, and the recording will be provided to all of you. You can go to the EU student launch, and there you can find the recording for this session, right? So if anything is left, you can go back and you can just study. And the PPTs will also be provided to all of you. Plus, I'm going to put some extra, the other methods also, which we couldn't do here because of the time constraint. And you can study about those methods as well. Okay, so thank you, everybody. Bye bye. Have a nice day.